Alright, here we go. I'm going to try to show you a couple more examples. And remember, these are equations. Alright, so they're going to have equal signs. And so whatever you do, you have to keep it balanced. Whatever you do to one side, you do to the other. Alright, so this is still lesson 11.7. We're solving rational equations. This is part 2. And I just thought I'd go through a couple more examples. So I believe this would be example number 3. Alright, here we go. 2 over n plus 1 over n plus 3 equals, so there's the equal sign. That's what makes this unit or this lesson different than the other ones. 5 over n plus 3. Alright, so I gave you the steps in part 1. And the first step is factor the denominators. So can this be factored? No. Can this be factored? No. No. So takes care of that. Next step, multiply every term by the lowest common denominator. So the common denominator is going to be, we need an n plus 3. And this is n plus 3 also. So we need an n and an n plus 3. So you're going to multiply by n and n plus 3. Okay? And you have to distribute that. You have to multiply that by each and every term on both sides of the equal sign. Alright, you have to keep it balanced. Alright, here we go. When we take this entire expression and we multiply it by this fraction, since we're multiplying, we're allowed to cancel. So this n and this n will cancel. The n's will cancel, but you'll still have the 2 and the n plus 3. So you'll still have a 2 and an n plus 3. And then there's a plus sign right here. Now you take this expression, multiply by this second fraction. And when you multiply this by the fraction, the n plus 3's will cancel. There's an n plus 3 and an n plus 3. So you're left with just n times 1, which is n, equals, and when you multiply this fraction by this expression, again an n plus 3 will cancel, n plus 3, and you're left with 5 and n. Okay, you just eliminated all the fractions. Makes this problem so easy. This is stuff you learned in pre-algebra now. Distribute. You'll get 2n plus 6 plus 1n equals 5n. Add the like terms. 2n plus 1n, that's 3n plus 6 equals 5n. Get all the n's on one side. Let's subtract 3n. 6 equals 2n. And then divide both sides by 2. 3 equals n equals 3. Oh, now wait, don't forget, you have to check for extraneous roots, excluded values. So you look just at the denominators, because the denominator cannot equal 0. So this denominator here, n can't be 0. Check the next denominator, n can't be negative 3, because negative 3 plus 3 would be 0, so n can't be negative 3. And same thing here, n can't be negative 3. So your solution is 3. Excluded values, 0 and negative 3. Alright, one more to go. One more. Alright, here's our final example. Now if I went too fast on any parts of this video, feel free to re-watch it. Just rewind and re-watch. You might even want to watch it 1 or 2 more times before next week's test. Alright, here is our last example. 4 over a minus 6 plus 1 equals, there it is, equals, that's what makes this different than the other lessons in this unit, 9 over a squared minus 36. Okay, so equals, that makes a difference. All right, step number 1, factor first. You only really need to worry about factoring the denominators. This is already factored. This is a difference. Difference means subtraction. Difference of two perfect squares, a times a and 6 times 6. Okay, we can factor. So we're going to leave the first fraction alone. Plus 1 equals 9 over, and a difference of perfect squares will be a plus 6 times the quantity a minus 6. I've got that memorized. I hope you do too. All right, now we need to find a common denominator. So we need an a minus 6 and an a plus 6. This one already has an a minus. So we need an a minus 6, and then we're also going to need an a plus 6. So we're going to multiply the entire equation by a plus 6 times a minus 6. Now you can only do this type of work when it's an equation, because you're multiplying everything on both sides of the equation, so you're keeping it balanced. If this was just an expression, you wouldn't be able to use this trick to get rid of fractions. Okay, here we go. When you take these two quantities multiplied by this fraction, the a minus 6 will cancel with the a minus 6. A minus 6 cancels. You'll be left with the 4 and the a plus 6. Plus, because of that, now 1 times this, okay, 1 times a plus, all right, that's going to be a plus 6 times a minus 6, equals, and then finally when you take this fraction times these two quantities, both of these will cancel, right? The a plus 6 will cancel, and the a minus 6 will cancel, so you'll be left with just 9. All right, no fractions. So here we go. We can't add. We can't add yet because there's multiplication involved. So here we're going to distribute. Here we're going to double distribute. So you get 4a plus 24 plus a squared minus 6a plus 6a minus 36 equals 9. So I just double distributed there. Well, over here I distributed, and here I double distributed. All right, looking for like terms. There's an a squared. There's a 4a. Well, we're taking away 6a, and then add, that's just 0, right? Take away 6a, add, that's gone. So there's a 4a. And then we have a 24 take away a 36. 24 take away 36. I believe that's negative 12. Okay, this is a quadratic because of the squared. So we have to put everything on one side and set it equal to 0. I'm going to move this up a little bit. Nope, can't do that. So here we go. Put everything on one side, set it equal to 0. So that means we have to subtract the 9 from negative 12. That'll be minus 21. And then you factor. What two numbers multiply to negative 21 and add up to 4? I think that has to be 7 and negative 3, right? 7 and negative 3. So you'll have a plus 7 and a minus 3 equals 0. All right? When you have two quantities multiplied to give you 0, at least one of these quantities actually has to equal 0. So to make this quantity 0, a would have to be negative 7. So a is negative 7. Or if this were 0, a would be 3. Because one of them has to be 0. Because 0 times anything is 0. So either this equals 0 or this entire quantity equals 0. So negative 7 or positive 3. So those are my solutions. Extraneous roots, excluded roots. You go back to where you factored originally, right here where I first factored. And here it cannot equal 0, so a can't be 6. So a cannot be 6. And then look over here. A can't be negative 6 because negative 6 plus 6 is 0. It can't be negative 6 and it can't be regular 6. And A can't be negative 6. All right. I hope this is helpful. Please ask questions if you're confused. Good luck.